yesterday we ran an experiment where we were looking at a double replacement reaction between our reactant sodium carbonate and calcium chloride. Let's all get onto the same page, the warm-up of our lab report form, limiting reagents lab making chalk. In our first question it reads, in a double replacement reaction, two aqueous solutions of sodium carbonate, let me go ahead and write that formula, Na2CO3, it is reacting with calcium chloride. Calcium with its +2, chloride with its -1, so we get our CaCl2. In the double displacement reaction, we see that the two positive ions exchange places. Calcium goes to the carbonate and sodium goes to the chloride. And as we predict our product, we would see 2 units of our NaCl, sodium chloride, and 1 unit of our calcium carbonate. And this is what we called our chalk during yesterday's experiment. So here's our balanced equation where 1 mole of our first reactant, sodium carbonate, reacts with 1 mole of calcium chloride, giving us 2 moles of sodium chloride, and calcium carbonate is our solid precipitate. Calcium carbonate is known as chalk. It says suppose we use the following made-up numbers as sample data so that it will help you follow the same calculations with your own data. Suppose as we walked with the scale yesterday, the first reactant was mass of sodium carbonate. Suppose it was 10 grams. And friends, I know that's way more than what we were asked. We're just making up sample data. Suppose we put that in with 12 grams of our calcium chloride. At the end of the experiment, when we were all dry, we had 7.5 grams. We would know as that as our actual yield of the chalk. Given a mass of the two reactants, we will work to determine the limiting reagent and from there find the maximum theoretical yield of our product. In our first set of experimental data, we will convert our mass of sodium carbonate into moles of sodium carbonate, and that's a mole mat problem. We start with 10 grams of Na2CO3. We'll multiply that by a conversion factor, just an old mole mat problem, moving from the scale into the center, where we'll convert to moles of Na2CO3. We'll need a molar mass for our sodium carbonate, so if I hit for that, sodium at 23 apiece, there's 2 of them, plus 12 on the carbon, and 16 times 3 for the oxygen. I found the molar mass to be 106 grams of Na2CO3 for every 1 mole of Na2CO3. 10 divided by that molar mass gives us 0.094 moles of sodium carbonate. Let's do the same